So welcome everybody for yet another Cassandra developer workshop. Today I am lucky. I have a very special guest, Maurice Eschold, co-founder of Typefox. So Maurice, thank you for being there with us. Can you please introduce yourself?
Yeah, thank you very much, Cedric, for having me. Yeah, I'm co-founder of Typefox, and we started several projects in recent years. One of them is SIA as an open source alternative to VS to VS Code, which is governed by an open source foundation, the Eclipse Foundation, and also a few years ago we started the project Gitpod that will play a very big role in today's workshop. And Gitpod is a great way of efficiently doing coding in your web browser with your workspace on the server end, on the server side.
Yeah, and today you will use Gitpod and you will see how good it is for any kind of development. We are using Gitpod every week, but if it's the first time you attend, you will see how cool it is. So, let's get started. It's not only me and Moritz on screen. As usual, there is a full crew behind the scene answering your question in the chat. I already seen David and Alex answering a couple of questions. You can also ask longer questions on Discord, and let's get rolling. Oh, by the way, if you like the content we are doing, don't hesitate to subscribe. Yeah, just saying, moving on. So today, as usual, we are live on YouTube and Twitch. I think we try LinkedIn today, so maybe we are on LinkedIn. Maybe the folks on the chat will tell me. If you need to ask questions, we are on the YouTube chat and also on the Discord. And today we will do some little games and survey live as usual using Menti. Nothing to install, simply open a new tab on your browsers, menti.com, and I will give you the link. Speaking of which, okay, so today we will show you how to build a reactive application using Spring Framework. And to do so, we will use as a database DataStax Astra, cloud database in the cloud, and as the IDE development environment Gitpod. There will be a backend and a front end. Moving on, it's simply just getting started. I know you want to get your hands dirty. All right. And first, don't wait. Let's explain you what is Astra. What is the database we will use today? So Astra is a managed service. It's Cassandra as a service in the cloud. Okay, it's provided by DataStax, but there is a free tier, and it's a free forever tier. So no credit card, nothing. You simply register even with your GitHub account, start a database. It will be there forever, 5 GB for free for you. And on top of this database, we do have tools and way to scale and API, REST GraphQL API on top of the database, okay, to ease as much as possible the use of Cassandra. And this is the reason why we will use that today, because it's free, easy to use, and you don't have to install anything. So Astra is software as a service. Yes. So, you know what? Let's get rolling. So everybody out there, hands-on part one. See, today's hands-on, no slide. There will be slide theory, but we really want you to get the most of this workshop and to start the app. You won't code today, so if you're a beginner, totally fine. I won't ask you to create a unit test to debug. No, everything is code. I will show you the code, browse how it works, but you should be able to start it. And first, well, you need a database. So go to dtassix.io/workshop or use the QR code you have on screen, and it will route you to here, how to start the database. Okay, So, and by the way, so today we are using a GitHub repo, DataStax Academy /workshop Spring Reactive. The link of the GitHub repo is below me, below the video, and it's forked from the Spring Pet Clinic. I will explain that later on. So in this repo, not only you have the all the steps to run the app, so start the database, okay? How to fill every single field on Astra, okay? Click Add a database, select the free tier, okay? When the free tier has been selected, the cloud provider has been selected for you because I know we are running this free tier on Google Cloud. But hey, if you can see that Astra can run on any cloud, and Astra is now multi-region, and Astra can do VPC peering with existing clouds. So if you already have some application in the cloud is one of these cloud provider, you can make Astra part of your ecosystem with the VPC peering. But by default, the database are set up on our own VPC. Select a region, pick the region that is the closest to you. So I am in Paris, so I pick Europe West. I did the screenshot, as you can tell. And when you're done, click Configure. Then it will ask you to provide database name, key space name, username. I give you here some sample values, but you can pick the one you like. Simply, please remember your password, because even if you can reset your password, it's always a bit annoying to have to reset your password. Yeah, you will have to provide the password in the end zone. Please, okay, ping the URL here. So the URL is just below the video, but yes, let me copy the URL for you in the chat. By the way, in the chat, I am DataStax developer guy, one of the people behind DataStax developer. So I put the GitHub repo, and David put the link to create the Astra database. Okay, we do have time. 2 hours is a long time. Let's take the time needed. So when you do have the database ready to go, with the active state, please do a send up. So for the key space name, you pick what you like. As a proposal, we put pet clinic, either for database name or key space name. But you know what? The application will be clever enough to use the key space you provided. So database name, I put pet clinic DB, and key space name, I put Spring _pet clinic. The only constraints I do have for those is really for the password. Now, I think you need to use at least one number, one digit, one alphanumeric character, one uppercase letter, and 8. The password would be at least 8 characters. Yeah, Spring Pet Clinic. Yeah, as Alex stated in the chat, it's not very important, but Spring Pet Clinic, yeah, that's what we will do today. Okay, and when you are okay, please give me some thumb up. I really want you to have the database ready, because then I will go to a few slides, but if you're okay, that's better. Okay, so and when you filled all the steps, now you can click on Create Database. Can I make my screen bigger? Maybe. There is no reason to keep this blank space on the left and right. And so it will take a few minutes to spin up. So we are just providing a new container, running Cassandra for you on the platform. So it may take a minute to start. Okay, Babu Rajendran, tell me is okay. Cool. So it's working. So Matt, okay. And yeah, simply do part number 1. It's hands-on 1 and it's okay. And you should have some. So Astra database. See, I'm signing with GitHub. Everything is Git star today. And see, I do have my database pet clinic in active state. Woohoo! Cool. So I will wait, let's say, 3 more minutes for you to be okay, and let's move on. Oh, started very fast. Cool. Cool, cool, cool. And when the status is active, see that you can now click on the DB and see that it's free. You do have 5 GB of capacity. You add a cluster ID and database username, pet clinic, and your password. So for Manta, when you need to choose your plan, you simply click free plan over here on the first part, okay? Just say, I don't want to pay anything, and it will ask you to pick one of the region, so pick the one closest to you, and just click configure, and just fill the parameter as stated or as you wish. So name of the database, I put pet clinic DB, so let me copy that, but you can put what you like. And so on when we say for key space Spring pet clinic, and for username pet clinic, and you will, you may see my password during the hands-on, but it's not a big deal because there is a client ID, client secret that you won't have time to catch. Or I will change it after the workshop because it's recorded, right? You can just pause and get my IDs. So Maurice, I know you did that before. How do you find the database creation process? Was it complicated or simple, straightforward?
I think it was rather straightforward. I mean, it didn't take us so much time, and when I look at the chat, it seems like people can follow.
Yeah, that's cool, and that's really the mean of this kind of live stream, is really to make people do stuff with you. Easy, cool. And so, okay, I will wait just a bit more for everybody to have their database. So you can see now that the database you can access to ELF, which will spawn a Grafana container and showing all the requests you are doing against your cluster. You do have access to SQL console, which is the shell to interact with Cassandra, very famous in the Cassandra world. We will use that later. You do have the Studio, which is a kind of Jupyter notebook, but for Cassandra, okay? So let me enter my password here. Just the shell, okay. And describe key spaces. You don't have to do that. I just try to fill the blank during the time. It's asking for credit card details. So if it does that, you did not pick the free tier. So we need to really say free. And if you already have a free database running, you can reuse it for today. But you can only have one free database in your Astra account. Okay, what else can I show you in the meantime? I can show you Connect, okay? You do have a running Cassandra now, and you can either use Cassandra drivers. This is what we will do today. I really want you to show how to use the Cassandra drivers, but on top of it, you do have the REST API and GraphQL API if you're a front-end developer really like to use GraphQL, then it's provided. So it's not only Cassandra as a service, there are some tools around that. And so not today, but on the sample app gallery, you can see that we do have a lot. So Spring Data, Jamstack for your front end, Next, okay, Gatsby, Spark, and the Spring Pet Clinic will be soon after this workshop. We'll be there soon. Okay, are we good? Should we move forward? Let's wait until 25 and we will move on. Okay, documentation, billing, database. Yeah, I do have a single DB. This is my dashboard. It's an active DB. I use the key space Spring Pet Clinic. I am on GCP for free Europe and capacity unit 1, which is the free tier. Okay, 1 more minute. And I will give you a little theory about reactive stuff. Okay, I think we do have people ready. Yeah, cool. So people follow, that's cool. I do have 25, let's move on. So today is all about reactive. And so to introduce you to the reactive stack, so just to remember, the database we just created is Astra. We do have a backend using Spring Framework. It's a Spring REST. It's a REST API using the Spring Framework technical stack. This is the part using the reactive. And we do have a UI, okay, a client. It's Spring Pet Clinic Angular, which is one of the UI implemented on top of, for the default reference application in the Spring community, which is the Pet Clinic. Okay, so first, synchronous. And this is for Java developer, this is what we use all the time, okay? When you want to use synchronous communication with Cassandra, you will connect, okay, initiate a session, and you will start executing query against Cassandra, and you will get your response, okay? So you will send the parameter to the API, the driver will create a query, what we name a statement. I don't go into the details today. You will bind the parameter, that's simply mapping parameter to the query. You execute the query against Cassandra, get back the result in an object called a result set, and finally you get the result. So what's the issue here? The issue here you can see on the slide is you need to wait during all that time, okay? So if you are running not performant queries, and in Cassandra you can do that. For instance, select star from a table without providing a where clause. It can take a lot of time if you query for a lot of data or a big cluster. Okay. So SWOT analysis. So strengths, weakness, opportunity, threat. For something we are doing every day, synchronous is very simple. But pretty soon you can hit the issue, the weakness, which is a blocking communication. So Cassandra is well known for high throughput, high volume type of workload. So meaning high throughput, if you need to wait for everything get insert to be completed, yeah, your high throughput is a bit compromised, right? So let's see if you can do better. Opportunity, easy to test and maintain, unit test, that's very the vanilla type of code we are doing day to day, okay? Easy to test, easy to maintain. Issue, scalability, okay? on a client, you have limited amount of thread, and so if most of your queries are blocked waiting for a result, maybe at some point you won't be able to invoke Cassandra anymore, not because Cassandra cannot scale, because Cassandra scale out a lot, but because of your client with limited number of threads. So how to cope with this limitation? So let's go asynchronous. Okay, that's the premise. So now with asynchronous, you will do the small step in the beginning, put the parameter, prepare your queries, bind the parameters to your queries, and boom, execute the query. But instead of waiting for the result, the Cassandra and the driver will give you immediately an object called a completion stage, which is in the family of completable feature of features, so the future API in the Java 8+, which is simply, okay, when the data will be ready, you will get a callback coming from that, and only then you can process the result. You know, on result, boom, you will process the result. So you will get an async result set, and not only a result set. On Cassandra, every single query is paged, and you will get the callback when the first page is loaded. Okay, by default, the size of a page is 5,000. This is a page size. You can make it bigger or smaller. For instance, if you are working with a web UI, there is no point to get 5,000 records. Yeah, maybe you get the first page. But yeah, the callback is per page. And you know, when you start processing the page 1, when you hit the last element of page 1, under the hood, the driver will fetch page 2 for you, and you can still process. But hey, what's happened if you get an error? You know, processing the result of the completion stage is not that easy. You do have two paths to handle. So first is success. Okay, you get the result set. I mean, async result set. You're happy, everything's fine. And the second is completion error, which is you get an exception. And so on the exception, yeah, you need to see, okay, do I throw an exception? Do I do some workaround? Okay, you got the point. So that's a bit tricky, but okay, that's still okay. Normal, error, it's kind of like a try-catch, right? But the issue is, in asynchronous, you tend to chain one call after the other just to have nothing blocking. I mean, as soon as I do have the callback for the first, I invoke the second as a callback and the third as a callback, and then you chain the treatment. And what happened is you nested every single code. And so each time you nested a new service, you have to manage two. Is it okay? Is it not okay? And now you get the ID. You get a tree of all the possible cases. Even the first level is failing. Okay, no problem. The second level is failing. So should I throw the exception up to the first level and handle at the first level, or process the second level, or do a workaround there? This is what we call the callback L. So what is cool with asynchronous is now you are not blocking anymore. You get immediately your futures. So you can scale. Okay, you can scale much more. Now your web threads are not blocked, but you get the idea. Now you can hit this callback L if the calls are nested, and you do have a maintainability error. Okay, and moving on to the promise, what about reactive? Okay, I put it in green because reactive is cool, right? Okay, so this is the reactive manifesto written by some clever guy telling that, okay, this asynchronous hell is not what we like, so let's try to put something better. And so they created the reactive manifesto. You do have the link on top right hand corner. And basically this is See, maintainable, extensible. This is exactly what we were missing with the asynchronous only stack. So what is a reactive service? So what we try to achieve is first the service to be responsive. That means the system always responds in a timely manner. Okay, if it's success or not success, you can expect the system to always answer the same in the same time frame. Second is resilient. Okay, the system stay responsive in the face of any failure. Third is elasticity. The system stay responsive under varying workload and adapt itself to variable ingestion rates. So that's a bit more, not really in the code, but more scale out, dynamic scalability, things you can achieve with Elastic Load Balancer on AWS, for instance, or in Kubernetes when you see that one of the pod is not responding, get the else check not running. Yeah, you may want to scale out this component. That's part of the reactive, what we want. And message driven, okay? Asynchronous is still at the heart of the system. So the system relies on asynchronous messaging to achieve loose coupling and isolation. Okay, that's the theory. What about implementation? Well, the leading implementation is the Reactive Stream API. Again, I put you the link. So Reactive Stream is really a specification, okay? And here you can see multiple implementation of this API. So here you do have Reactor, Vertex, Akka, and this is a logo of Spring WebFlux leveraging Reactor. Okay, so what object do you find in this specification? Well, you do have the subscriber and a publisher, okay? And so the subscriber will send a request to subscribe. The publisher will get you an object named a subscription. And you, as a subscriber, you will query your subscription. So now you do have an object as a subscriber, and you won't query the publisher. You will query the object you have, the subscription. You execute, everything asynchronous, and then there is a callback on next, okay, to get the result on next. And you know what? Now you don't have the notification, the callback for every single page, but for every single record. And this is why when you speak about reactive world, you think about nice UI that refresh automatically, because the item are sent back to the UI, and the idea is anything happening on the DB, you get the callback, you get the notification per record. And so this notification can be bring back up to the API layer, and framework like React, Angular, any JavaScript now is able to read that notification coming through the UI. You are probably as aware about WebSocket, and boom, the UI can be refreshed automatically. So it's now callback at the fine-grained level, and so you can do fast and small things with this new callback, but also you can do more. So if you look at the Cassandra code, but it's quite reusing the same publisher subscriber mechanism. And now when I execute, when I bound my statement, I get a flux. So flux is one of the objects used by Reactor. Reactor is a leading implementation of the reactive streams. Okay, reactive stream specification, Reactor main implementation in Java, and so tools like WebFlux will leverage on this Reactor object. So in the code, you will see either Flux, which is kind of a list in the reactive world, and Mono, it's a single result in the reactive world. You execute a query, and now coming from Cassandra, you do have a callback for every single row. Okay, and which is neat is if you can keep up, there is tons of things happening at the Cassandra level, and you as a client, you are a subscriber, and you cannot keep up with that. Well, there is a back pressure mechanism to tell Cassandra, okay, please driver, slow down, I cannot keep up. And that's the sweet, that's really what's cool. Cassandra is famous, high throughput. If you cannot keep up, yeah, now you can tell Cassandra to slow down. It's for read, but not for write, because there is no way Cassandra could tell you, stop writing, I cannot keep up. But it's not the topic for today, but on a single node of Cassandra, you can expect about 3,000 transactions per second and per core. So on a machine with 8 CPU, it's about 20K requests per second per node, and Cassandra is a distributed system with basic production 3 nodes. So basically, very basic, Cassandra can absorb easily 60K requests per second. So as a client, you need to be pretty strong to hit that value. But anyway, just telling you, the back pressure is only available for read. Okay, that was a lot of theory, right? Okay, and this reactive, we will apply that to the reference application which is in the Spring community, which is Spring Pet Clinic. So if you go to the spring.io, you will find the reference implementation of the pet clinic. But the pet clinic is so famous and so widely used as a reference app that now there are some people forking and changing the implementation in new way. So I hide a little bit. It's so you can see, you can go on spring-petclinic.github.io and you will see multiple implementation for this sample. See, you can see here the Angular, the microservice, using all the Spring Cloud stack, and I'm happy now the Spring Reactive is part of this organization. So again, this organization is community oriented, okay, maintained by people like Antoine Ray, very active, answering ticket very fast. So thank you to the community, pretty happy to be part of it. And if you start creating some ticket with the sample we are using today, I will probably jump on it. All right, we do have the database. We know that we will use Reactive. So let's move now to the development platform. And on that, I will let the expert speak. I will let Moritz take over. And I will get back to my screen later on. So let's see. Okay, now Moritz, you share your screen.
Yes, I do. Do you see my screen?
Yes, we can see.
Perfect. Yeah, thank you, Cedric. So let's go a little bit deeper into a development environment that runs inside your browser, that runs inside the cloud. So let's take a closer look at Gitpod. Here on the left, we see it running. We see a screenshot of it running. This is basically the website. So if you go to gitpod.io, it's super easy to just click on this button, try now, and all you need is an account on GitHub or GitLab or bitbucket.org. And with Gitpod, you get an IDE that has quite a bunch of features that focus around being ready to code immediately, and that focus around collaborating with colleagues, and also that focus around being powerful enough for professional developers, and that focus around reproducibility, so that everybody who's working on the project gets a reproducible workspace or multiple reproducible workspaces. And in more detail, so for teams, we support code reviews and sharing of workspaces and exchanging workspaces snapshots. and to offer really, really fast workspaces. When you think of what you traditionally need to do when you start developing, traditionally you would clone a project and check out a branch and study the readmes and install the tools and run build and run test, and then after a few half an hours, or even days, you're finally ready to code, and Gitpod automates most of this, so that from choosing a project to starting to code, you can do this within seconds, and that's what we're gonna do. And you can follow this along with me. I will provide you links in a minute. It's free for up to 50 hours a month. And for people that want to use it more professionally or more extensively, we also have paid plans, because running a full-fledged workspace in the cloud is actually quite a heavy thing that also creates costs on our side. So to follow along, you might open up Gitpod either on GitLab or on GitHub by following these QR codes. And as you do it, I will do it as well. So I will switch to interactive demo mode. So for example, if you go via GitLab, here in
Yeah, so the project is available on GitHub, GitLab, so you can pick what you like.
Yes, exactly. For some reason, here I'm not signed in for some reason. So just a second. Right, so when I'm on this project and when you're signed into GitLab, you have probably seen this this button Web IDE before. And since a few weeks, there's also a second button or another option in the dropdown named Gitpod. So if you click on that one, then a Gitpod workspace will open. And we have this native support for Gitpod in GitLab since a few weeks, because we Gitpod, we started a partnership with GitLab. So we will be working together to make this work really, really easily. The same works on GitHub. So if you go to the GitHub project, you could either install a VS Code extension that installs the Gitpod button here, or if you do not have this VS Code extension installed, you can go to gitpod.io, or you can prefix the URL with gitpod.io/pound and press enter. And then a workspace will start on this project. You may need to log in to Gitpod. That's something I did already. you can do that with your GitHub or your GitLab account. And what's happening now is that Gitpod starts a workspace for me, for you, in the cloud. And now we have a running workspace. And when we take a look at the workspace here in the middle, there's already a README file, the README file from the repository that is open in an editor, but I will close this for now. Here on the left-hand side, I have all the files from the repository. And here on the bottom, I have terminals, and there's stuff happening already. And if I open up a new terminal, I can also see it's a bash. We are under Linux. We can run any Linux commands, and we see that we have quite a powerful machine where we can just do stuff on the server side. And here we see that our pet clinic project has already been compiled, and we see this message, or we see that it has been compiled because here we see the last message from Maven that tells us the build was successful. It took 1 minute 40.
Thank you, Maven.
And we know we didn't wait 1 minute 40. When we open up the workspace, this was already done. And that's a feature of Gitpod. We call it pre-builds. So what Gitpod can do is Gitpod can run such tasks ahead of time, like before I start a workspace. Gitpod does this like a CI/CD server. So basically, when you do a git push to your repository, then Gitpod gets notified, builds a workspace for your new commit, and stores it in the cloud. And later, when you need that workspace, it's just there and ready to code. And you see this nice message of, oh, you just saved 2 minutes of watching your code build because that ran ahead of time.
Cool.
And same for Angular. And this application, or the application automatically ran, so we can now open this up in a browser, for example, or I can also open this here in a preview, then I see it in Gitpod. And now we see the Spring Pet Clinic app running live inside my workspace. So the full app. So basically, I chose the repository, click on a link, have the running app have a running workspace with the app running in it. Takes less than a minute. So that is, I think, record-breaking time for going from 0 to being ready to code. But let's look a bit more into the details on how we actually made this work. So the entry point for this, what Gitpod uses, is the Gitpod YAML file. So that's a configuration file that you can place in your repository, and it's very useful to place it in the repository because this way it's version controlled and shared with your team. We call this dev environment as code, and the big advantage of this is that the setup of your dev environment is always consistent with your code, so you can be sure you get the right version of VS Code extensions and tools and so on. And the first thing the gitpod.yaml file does is it says it instructs Gitpod to take this Docker file as a basis for the workspace. And when we take a look at this Docker file, we see, oh, it takes a workspace full image, installs Angular stuff, and installs even more Angular stuff. And when we start a workspace, what Gitpod does is it takes this Docker file, creates a Docker container from it, and launches this as my workspace. Yes, absolutely.
Let's make that a bit bigger.
Is this better?
Yeah, I think just waiting for feedback, but
All right.
yeah, zoom in the screen, yeah, like Command plus, just to make that.
I can do that too.
Yeah, perfect. And make your, yeah, perfect. You can put back your brother full screen now.
Too much overlap.
Yeah.
So what Gitpod does is it takes this Docker file, and like when you start a workspace, it checks, is there such a Docker file in the repository? And if that's the case, it builds a Docker container from this Docker file, and that will be launched as your workspace. So basically everything that you install here inside the Docker file will be inside your workspace. So you have it, for example, accessible here in the shell. And you don't need to base it on workspace full. You can also base it on Alpine or Ubuntu or Debian or other Linux distributions. And so that is a very, very, very powerful way of creating a dev environment which is exactly tailored to your project, and at the same time giving you a very convenient control over how you manage it, because it gets version controlled with your code. And inside the Gitpod YAML, what we can do is we can specify tasks that should run as a pre-build. So for example here, or let's look at React here. This is the command for the pre-build. So for the pet clinic example, we run the command maven clean package install as a pre-build. So just like a CI/CD server, if for example Cedric keeps on developing on the app and pushes to the Git repository, then Gitpod will run this command to create a fresh workspace from it, store it in the cloud, and later when Cedric or I want to start a workspace on that commit, then we get everything pre-compiled and can be happy about this message. The command, then later the command actually gets executed when you start the workspace. So
Yes,
this command made sure that when I just started the workspace that we could already see a running app.
Yeah, and this is why a question we asked to enter your credential. We will do that in a minute. This is setup.sh that will use the credential coming from Astra, initialize the app, and start the app.
Yes, exactly. I will pass over to Cedric in a while, and then I assume you, Cedric, are going more into details about that one. There's a bit more conflict here about ports. So for example, the React app is, or the pet clinic app is opening up port 4200. We need to expose those ports to show them in a preview. Config to enable the previews, and also pre-install VS Code extensions that I will talk about more in a second. But first, I want to show to you that this is actually this is a real IDE. This is not a toy thing. So Gitpod supports VS Code extensions, and here we have Java support installed via VS Code extension. So the Java support that you see here in Gitpod is exactly the same that you see in VS Code, because it's the same VS Code extension as what VS Code uses. And the VS Code extension actually packages the Eclipse Java tooling language server. So when I, for example, hover over a command and I see the Java doc, that is exactly the same that you would see in Eclipse. Or if I open some class, let's go to some YouTubes and press content assist, and I get the real content assist. So this is like exactly those functions that I can actually open up on this class. This is not a wild guess based on text scanning. Or if I do a control click and click on this, then I can also navigate to the implementation. And we see that this Java code, this is not from my repository, but this is from associated with the local date.class. So this Java code is somewhere deep in a jar file in my workspace. But nonetheless, for convenience, it's super easy to access it because it makes coding so much easier when you can actually read the codes that you're calling. And what else? Other features that we have. We can also find references and see where this is being called from. There's something that's not working. And one more thing that we can do is we can also debug. So for example, I can go here to my Spring application, I can set a breakpoint, and then I can click here on debug. And then on the left-hand side, in the debug view, I can see how the application starts. Oh, that's a lot of information. Now I'm really running out of pixels with my resolution.
Yeah, and you did not provide the credentials
that are running in the Java virtual machine, and here I can see the call stack. And now, for example, I could click here to step into the method, and now I'm starting to step into the Java Spring framework.
Yeah, that's cool. I do have a couple of questions coming from the chat now. So first is, does the workspace you are using keep the states? You know, is stateful? You can go back and...
Yes, absolutely. So the workspace, as long as you run the workspace, it's your Docker container. So you keep all the files, all the processes, and so on. And when you close your browser window or when you click on Stop Workspace, then the files from the workspace will be saved in your user profile, and then in your user profile, you get a list of the workspaces that you launched recently, so you can always go back to them and start them again.
You like our app. And second question is about shortcuts. So is there any shortcuts close to what we get used to Eclipse or IntelliJ?
Yes, absolutely. So if you press Command-Shift-P, or if you or go to View, Find Command, it's just like in VS Code. So you get a list of all commands that you can run, and you also see the shortcuts that are already associated with those commands. So you can use all those shortcuts. And you can, additionally, you can install VS Code extensions that change shortcuts. So for example, you could install a VS Code extension for VI shortcuts and thereby make it behave like VI.
VI, whoa! No, that's
yes. Only do it when you know how to exit. But
oh, geez, oh yeah, don't tell me about that. That's cool. So it leverages on kind of VS Code, and you can install multiple extensions. By the way, in this app, you already have 2 extensions running.
That is very, very true. So let's take a look at this. So here we have an extensions view, and in this extensions view, I can, for example, search for. I have the Lombok extension installed, and I have the Spring Boot extension installed, and there's also a bunch of built-in extensions that are pre-installed. And here I can, for example, simply search for other extensions. So I can search for Java, and then I find a bunch of other extensions where I can simply click on install. And then when I click on something to install, I don't know, let's install the Maven stuff. Then I can choose whether I want to install it for this project. When I install it for the project, then goes into my, I get a marker in my Gitpod YAML, then it will be shared with my team. And when I install it for iSalt, so that's myself, that goes into my user profile. That is where I should put my VI shortcuts or a theme that uses coloring that not everybody might like. Yeah, then it goes into my user profile and will be there on my projects, but it won't bother my teammates. And to show what these extensions can do, I already showed that we have the Spring Boot extension installed, and if I go to resources and to application.yaml, so this config file from Spring, and then press content assist here. Oh, it's not so super fast. Then we see we get content assist for this YAML. So that is this content. So the IDE knows exactly which values are acceptable here, and that is provided by the VS Code extension for Spring tools. And I also just noticed that the find references that I wanted to show earlier, it actually popped up here on the left-hand side. I expected it elsewhere. That's why I was a bit confused. So the find reference feature actually works nicely. And to really benefit from this when you work in a team, there's a few ways that make it that are super powerful when you want to work with Gitpod. One is reviewing pull requests. So for example, now when I go to some other repository, here is the repository of our IDE. And open this, then I will get a new workspace that starts, and it doesn't matter that I already have a workspace running. So this is what I want to show is it's super convenient that here I don't need to interrupt my work just because I want to review a pull request elsewhere. I can have several workspaces that just without problems run in parallel.
Okay. Question in the chat, can you use like private Git like AWS, Azure Codebase, or a Git URL you would provide?
You can use private repositories from github.com, gitlab.com, and Bitbucket, so they will all have support for private repositories.
Okay.
We also have support for self-hosted GitLab installations. So if you self-host GitLab somewhere, we can also hook this up. And on top of that, we offer, or you can self-host Gitpod. And when you self-host Gitpod, then you can hook it up to mostly anything that supports OAuth. And that can also be a GitHub enterprise server or your self-hosted GitLab. And when you self-host Gitpod, then of course you also choose each cloud infrastructure. So then you can choose, for example, run it on Google Cloud Platform or AWS, and we're working on Azure support.
Okay, nice.
And so now here the workspace for my code review is almost there. And here, for example, I see the files that have been changed, or here's only a file that has been added. And when I click on details, I can also see the PR, and then, for example, I can click on review, or I see all the conversation from the PR, and I can conduct my review. And inside the file, I can also comment on individual lines, and that all gets uploaded to GitHub.
Cool.
And even more when you work in a team. Let's say now I'm doing some coding and I'm stuck with something on Astra, but I know that Cedric can help me. What I could do is I could click here on my avatar icon, and now I know that Cedric is with me. So what I could do is click on share running workspace. So I could invite Cedric to enter my running workspace, and then we could together work on the same code. That also works nicely for educational settings or for mentoring and unblocking, obviously. But even if Cedric would not be there with me right now, but I know that he's super busy in another meeting at the very moment, but hopefully later today he might have an hour to look into or to help me out. What I could do then is I take a snapshot from my workspace. So a snapshot is like the current state of my workspace persisted in the cloud. And when I take a snapshot, I get a link. So now Gitpod is taking the snapshot, and once we have the link, I could share the link via email or via chat. And if Cedric would click on it, then Cedric would, here's the link, would get an exact copy of my workspace. So the copy is like fully detached from my workspace, but it contains the files exactly as I left them. So Cedric could...
Including environment variables and all the modification you did. Cool.
Yes. That is super useful for async work or for handing out exercises.
Yeah, or multiple
bug reports.
Multiple state of your exercise, You do have, basic, then step 1, step 2, step 3. If you're stuck, go to link step 3 and everything is done for you. You can move on for your exercise. So really for any university or any school, so not only students don't have to install anything on their laptop, but you could have your courses ready to go with multiple commit and these workshop snapshots stated to each commit.
Yeah, that's a big part of that's my demo part.
Which is cool.
Thank you. If there are more questions, please post them now in the chat.
Yeah, not yet, but I will watch, and if there are, okay. Let's take the question. So should I take over and
finish up? There's two more things I want to stress first.
Yes.
As I already mentioned, you can use Gitpod on gitpod.io, or you can self-host it. We have Terraform scripts to install it on AWS and GCP. And we have a Helm chart to install it on Kubernetes. And we recently went open source. So you can actually look at the source code of Gitpod and compile it yourself, try it, run it, and of course improve it and contribute. Yeah, with this, I'd like to hand the lead over to you, Cedric.
All right. So let me go there, and let's do some little slides. Yeah, let's go with slides. Okay. Yeah, just two questions maybe we should take now before running, because it's question relating to the snapshots. And first is, so the snapshot is just a copy. It's not a link together with the original. And so then is, how do you merge a snapshot with the original, back together if you need to?
With Git. So if you create a snapshot and thereby you basically branched off your workspace, what you would do is you would commit the files that you want to keep to Git, and push them to your repository, and then use the mechanisms of Git to align them. So you would rebase or git merge, however it is necessary. And if that is not an option for some reason, of course you can also just download files from your workspace to your hard drive and upload them to another workspace. But
Git is
that's
a way,
just the last resort.
Yeah, I think Git is the way. Okay, that's cool. That's cool. Pretty neat. Okay, let's go into a little bit of Spring and using everything we saw just to build the application. Will you? We still have time, so let's go into it. So a couple of weeks ago, we introduced you Spring. So it was 2 hours only on Spring and Spring Boot. So I won't go into the details today. I will go fast, but at the heart of Spring, the mechanism that make Spring a superstar in the Java community is really the inversion of control. So now you define a single interface, multiple implementations for your interface, and when you need to use this service, you only specify the interface and not the implementation. Doing that, you introduce loose coupling between the user of your service and the service. So it's very easy to do mocking, to do multiple versions of your service, and even if you have a single version of the service, most people doing that all the time now. It's so cool to introduce some decoupling between layers of your applications. So last time we introduced you the Spring Boot, which is a runtime with everything included in Spring, and if you need more function, you add some Spring Boot starters. So Spring Boot starter data, Spring Boot starter security, Spring Boot starter FF4J, why not? I mean, so today we will move to the reactive part, okay? So it's still running inside Spring Boot, but now we are using something called Spring WebFlux. So this is Spring Boot with 3 layers: presentation layer, business layer, persistent layer, using inversion of control in between layers, okay? And Spring Boot will help you package your app as a standalone jar, which is pretty convenient and easy to deploy as container. For instance, you don't have to deploy your app in application server. And I told you, adding some starters, you add some metrics, health check, configuration. By the way, in the sample today, in Gitpod, we are simply using the REST API. But if you go to application.yaml, you see that you can enable Spring Security, distributed tracing with Zipkin, and also Prometheus Grafana stack. It's all there. You simply have to enable the flag when you start the app. So it's all due to Spring Boot and the Spring Cloud world, providing all the dependencies you need. Simply attach what you need. So speaking of now reactive Spring. So this is the key slide. So what you used to do with Spring MVC, which is the web layers for servlets in the Spring world, both for REST API and controller in a MVC pattern, model, view, controller, where the view tends to be with free marker or time leaf in the Spring world, and the REST API, of course, using the REST part of Spring, and you can only use REST controllers and have your UI using any JavaScript stack, of course. So endpoint, it's moving from MVC to WebFlux, but that changed something. If you introduce WebFlux in your class path, now all your application must be reactive. That means Spring will scan all your classes, and if one method is not reactive, it's synchronous, for instance, the application won't even start. Okay? It will tell you there you do have a blocking call, I'm not starting. And so now, because you introduce some reactive at the endpoint, because all the nice features I showed you before, fine-grained notification, now you need to be reactive to the full stack. So full stack means at the database level, when you interact with the database, so at the connectivity, meaning the driver levels, then in each layer of your application, repository, service, and controllers. So for the connectivity, because we are using Cassandra, we're of course using the Cassandra drivers, and the Cassandra drivers provide now ways to execute method in reactive way. So then, two ways to work with this reactive connectivity stuff. You can either use Spring Data Reactive Cassandra, Spring Data Reactive Cassandra, which is a wrapper around the reactive driver from Cassandra. This is not what we are doing today. Today, we are simply leveraging all the features from the driver, not Spring Data. Because my point is Spring Data is very strong, but it's like really building a boat inside a bottle. So with Spring Data, you do have nice repository, okay, where you simply have to define interface and entities and method with convention. Creating the proper method name will execute the proper query. But what happened under the hood? Now, what about batch statement? What about paging? What about consistency level? All these features from the driver are hidden for you, and you tend to forget them and always use the default mechanism. It's not the Spring Data fault. It's because Spring Data is so easy to start with that you are doing the default method, and it's not what you should do, because there will be way better things to do to be much, much faster. So what I did today is I simply use the driver to see everything it can do for you. And later you can use Spring Data Reactive to get that, to make that happen. And with Spring Data, when you get stuck with the repository, you switch to Cassandra class called Cassandra operation, Cassandra template, and guess what? You are using the class from the drivers. Okay, so I do have the implementation of the Spring Pet Clinic app using Spring Data Reactive as well. That could be another workshop. So today let's dig into the real thing, everything you can do with Cassandra driver without being constrained by the overlay Spring Data. Okay. Okay, so backend code review. All right. So first, at the database level, okay. So I implemented this app, and so I took a model which is relational. Okay, if you look at all the existing implementation of the pet clinic, it's only relational SQL, and so there are some joins all over the place. So the business domain is pet clinic. You do have pet you do have owner owning pets, and the pets can go to visit, and for the visit you will contact a vet, which is quite easy. So you totally understood foreign key between owners and pets, foreign key between pets and visit, and integrity constraint, visit, pet, vet. In Cassandra, no joins, no integrity constraint, no ACID transaction. And so I simply use the method that is explained in DS220 on this channel, is thinking, take your entities, take all the query you need to build your app, and try to first doing one table per request, even if it's mean duplicate the data. It's not a big deal in the Cassandra world. I know it's surprising for people coming from relational. This is how it works. Don't be afraid to duplicate the data. And so after that, I try to find ways to maybe reduce the number of tables, and it ended up doing this data model. Okay, so moving on. Okay, then is connectivity to Cassandra. So connectivity to Cassandra is done by the drivers. Maybe I will show you how it works more in the code. And the repository service controller. So I put here the schema, the architecture. You do have the same in the GitHub repo. So what you simply need to realize is you will have mostly a DAO for each entity. And then for services, you can have one services per DAO, or you can use the business service layer to aggregate and compose data coming from multiple DAO. And what is cool with the reactive is now if you need to get all the pet from an owner, you may still need to do n+1 select, so get details for every single pet. But with the reactive stack, you can do that all together and get the values for every single pet asynchronously and get the result when you get all the requests. All right. Okay, so now let's go to the code, okay? All right. So we add a database. It's running. We are happy and we do have an empty key space. What I will do is I will copy my credentials just to have values to be used in the Gitpod. So what I do, so I follow the step written there. It's pretty quick, okay? It's simply create a service account and copy the credential. So if I go to my database, I will go on the top, click on my name, okay? This is what has been asked. Scroll down to the bottom just to see the security settings. I do have here my security settings. So if not, I will add a service account. And boom, I do have a service account. From there, I will go here and say copy credentials. Okay. I can maybe open, can I open? Yes, this is not what I want. Yeah, so this is what is in my clipboard. It's a JSON with my client ID and client secret, the thing you need to make pause and steal all my data in my database. But yeah, it's a demo database. I will eventually terminate the database now after this workshop. All right, so with this credential in my clipboard, let's get started. I'm going to GitHub, okay, and I will use the open in Gitpod button I put there, but because I use the extension shown by Moritz, I can also simply click on Gitpod button over here and see, look at the URL, it will open Gitpod and use my Gitpod. So it's starting. Let me hide this guy. Is it security credential per DB per account? True. Per service account per DB, I guess. But now you are asking, I should try if I cannot access another database with the same account. Because it's at the organization level. So I can probably contact multiple database with the same service account. This is a question to ask to people at DataStax, because you know what? I always use the free tier, so I always have a single database. Okay, so 2 tabs. One is the UI. Okay, everything has been done for me, and the UI is already running on port 4200. So I can open the browser, and the UI is there. But the UI cannot contact the backend because the backend is not started. So if you look at the backend tab, okay, I was asked to provide my credentials. So guess what? I will pass my credential, which is a JSON. So this is a small setup.sh script I have created for you. And what it's done, it's simply creating some environment variables. Oh, it did not ask me for my password. Whoa, that's so strange. Not that much, because in the Gitpod world, even if you delete your even if you delete your workspace, you can keep your environment variables. And so Astra DB password was already there, saved, and so I had there is no point for me to provide it again. Okay, so see, so now the database has been started. I can open the database. Okay, first I show the full demo, then I go into the code. So now the backend is started. And so one call you can make, it's going to the pet type because it's referential data. So it has been populated for you. So what the application does as startup is creating the expected tables and putting data where needed. You know, that's pretty cool. So I can see what are the pet types in the DB. Okay, so I will go try it out and execute. And see, those are all the pet types available in my database. And so during the time you are starting your backend, I can go to my database, maybe here, show you the SQL console. You don't have to do it. Simply, I will wait for you to start the backend. Copy your credential, copy in the terminal, provide the password, you're good to go. And so remember, Gitpod has downloaded all the dependency, did all the Maven command for us, and also execute the pre-build. Okay, so describe key spaces. Is it big enough? Should I make it bigger? Okay. So describe key spaces. And see, I use Spring Pet Clinic. Okay. Describe tables. Okay. Yeah, if you just created the database, you don't have to provide user password. This is because I'm using an older database and the no password to provide to open the SQL console has been released a couple of days ago. Okay, so these are all my tables. And if I want to see all the pet types, you know, the one I show you in the Swagger UI, I will go here and I will do simply select from. Okay, so now the pet types are those guys: bird, cat, dog, hamster, lizard, snake. All right. I can create a new one from the Swagger, but you know, that's not the point. What is pretty neat is, look at that. Gitpod just open a public API. So the API was expected to run on 9966. So what it does is simply map into 9966 on 80. And now everybody can access that. You could access this URL if you wish. And so what we did in the beginning, in the launch of the Angular, we simply evaluate with GP URL 9966 what should be the backend URL. And like that, cross finger, if I click on pet type, now the UI is communicated to the backend. And I can add a new, so let's see, lizard, dog, cat, what's snakes? So what kind of pet do you have, Moritz? A lion, okay.
You have a turtle.
Oh, turtles, yeah, why not? Okay, so now let's go to the turtle. So I'm editing the reference table. If I go to the database and ask for the data, of course it has been updated, okay? It's not a mock. We are communicated from this UI to the database. So, and you know, before going to code, let's make a poll. That's cool, right? We do a full working app with UI and backend and database, and you don't have to install anything. And it's free. All right. Okay, moving on. So let's go back now to the heart, the code. And to show the code, guess what? I will use my ID. No, just kidding. I will use Gitpod. Okay, so remember, first, let's go each step. First, the connectivity. So if I go to main, Java, everything is there. Conf, okay. Conf and maybe application.yaml, which is the Spring Boot configuration file. Okay, so This is the one Moritz opened before. Let's make it bigger. This is a configuration file. I have enabled some actuator, Spring. See, you can enable Zipkin by simply enable true. You can enable using the Spring security by enable true. And you can either use Astra, which is a default behavior I do have, or you can use local Cassandra. If you want to use Zipkin, local Cassandra, Prometheus, Grafana, you need to start all these components using Docker, and the Docker Compose is there for you. Everything is there, okay? Prometheus, Grafana, Zipkin, Cassandra, yada, 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 everything is there. So if you want to run everything locally, do it. The Docker Compose is there for you. But today, everything is in the cloud. So let's see. I do have application-astra.conf. So to set up the DataStax driver, you simply need a single conf file, application-astra.conf. Okay, and this file can have hundreds and hundreds of fine-grained configuration key. So first, if you use Spring Data, now you need to use the small keys, I mean the limited number of keys available in application YAML in Spring Data, and you have not access to all these stuff by default. There is a way to do it, but it's not well written in the documentation. Yeah, you simply go to basics and do basics. So first look at that. So this is the Astra conf, okay? So I'm using environment variables I have created when I've imported the JSON. I do have the same file for local configuration, and now I'm using Docker Cassandra 9042. Okay, so level 0 configuration files. Okay, level 1 config. So what I do, Cassandra config. Okay, I will define a bin SQL session, okay, implementing synchronous, asynchronous, and reactive calls. Okay, simple as that. And depending of the flag use Astra, I will load one file or the other. Okay, very easy, very basic. You got the idea. Maybe one thing to say about configuration before going further is I use Spring Security, and if you enable Spring Security in the application.yaml, you will use one class, security enable config, okay, implementing a filter with Spring. And if you disable, you don't have the Spring security filter. And same for the security, Swagger, the small framework we are using to generate this UI. If you disable the security, this is what it looks like. If you enable the security, there is a new button over here to provide user as password as HTTP authentication basic. All right, config. Okay, now what about DAO? One step above. Okay, one step above DAO. So let's pick one of the entity. They're all working the same. Pick one entity and see what's going on. Okay. So let's pick vet. Okay. So vet at the DB layer. First, create an entity. Okay. So we are using Lombok not to create any getter setter. It has been done for us at compile time. It's an entity, okay, nothing much to say about that, but we are using annotation, or those annotations come from the default drivers, not Spring Data, I told you, but you can do quite the same with Spring Data. So here the partition key, clustering colon, provide name for the columns, and with that you do have a mapping from object to the tables. So let's use that in a DAO. So like Spring Data, in the default Cassandra drivers, there is a DAO mechanism, so-called mapper, where you simply define the interface, and code will be available for you as is, okay? And you create a mapper referencing the DAO, okay? But now, you do have access to the SQL session. So that means you can here easily create the tables. So see, in the mapper, I create the different table using my SQL session. It's available for me right here. And then at the DAO level, I can define some advanced queries in the select over here. Okay, that's entity level. Now let's move to service level. Oh, by the way, so at the driver level, all the method will return map reactive result set. And the reason is the driver won't force you to use either Reactor or another reactive implementation like Vertex. So it provides you the publisher, which is the interface, the specification. And so because Spring WebFlux is using Reactor, at the service layer, when I invoke my DAO, so this is my service, okay, injecting multiple DAO over here. And so look at that. I will say Flux. Remember, Flux is really the class you want to use when you return a list of something. So the DAO got me find all, which is a mapped reactive result set, and I map that as a flux. And now I can move from any entities to the vet entity, which is the entity used by the service layer. Remember, that's basic Spring stuff. At each layer, you want to have dedicated entity. At DAO layer, I have vet entity using annotation related to my implementation, my database. Then at the service layer, I don't want any dependency to my database. So I create a new classes, even if it's exactly the same, but most of the time there are some mappings because this class, we get some info coming from multiple DAO. So what about using URM? So in Cassandra, there is no R, okay? There is no relation. So we are using object mapping because there is no relation. Joins does not exist in Cassandra. So this mapper or Spring data are really the object mapping. So it's kind of Ibatis Hibernate if you wish. Look at that. If you look at the DAO interface, I will, select, delete, update. See, I update and I provide my object, which is really like connection.save in the Hibernate world. So, but we do have an entity. I save my entity. I update my DB. But no, it's OM, not ORM. They're kind of the same. But it's not hooked. It's not magically, oh, I will update my object and boom, it will magically update my database. So I have used Hibernate back in the day, and the developer manipulating the this data, this object layer, and having some updates in the database, I can guarantee that DBA ate that because you're not aware of which kind of query you are firing against the database. And this is one of the reasons that now people tend to put API on top of the database because they don't want you to execute any query because you have fun with the ORM. True story. Okay, so that's your DAO. Let's move to the service layer. So I translate the result set from mono or flux, depending on what I like, and I'm using a mapping to map the entity from DAO level to service level. So if I go to the mapping, let's see, I do have some utils mapping. That's, okay, stupid mapping, field to field, okay. Put that field in that field, put that field in that field. There are some framework existing to help you with that mapping, but my point of view it's faster to do that like that instead of expecting some yet another layer of annotation to do the mapping. That's just me. You can do whatever you like. So I do have my services over here. Let's see what I have. It's simply, it's really code like you would code now with Java 8. it's all about, it's really close to using streams, reactive streams. Once you get either a mono or a flux from the result, now you can do map, okay, mapping from one object to another asynchronously for every single record. You can flap map, so you can do the same, but in a dedicated async call for every single item. And so, at the controller level, Spring WebFlux, we expect to return either mono or flux. So make sure that at the service layer, everything has been done for you. Just the last word on these classes is look at that. At initialization of the class, because I do have after set properties, I have implemented initializing Bing, just Spring stuff. This is why the database is filled when you start. And by the way, everything in Reactive is lazy. If you simply create the mono, if you don't have anybody to subscribe to this mono, nothing will happen. You need a terminal call. And this is why I put a little subscribe in the end. You do not want to do .block, because .block will get you everything what you need. But I can guarantee if you put some .block in the code, then Spring WebFlux will go after you and say, I don't start, I saw some blocking code. Okay, so and now the controller layer, and it's all working the same. So now I keep reusing the same annotation from Spring MVC, Spring REST, so it's still get, Swagger API are still the same. Now instead of returning a list of vet, I return a flux of vet, like that. So really, at that point, controller is all about boilerplate and logging and error management, because all the code to compose has been done at the service level. And service level is all about aggregating data coming from multiple DAO, using the nice features coming from Reactive, the flat map, and enrich the object, populate the object from source coming from multiple data asynchronously. And then see, it's pretty close to what you have in default Spring Boot app. Simply now we need to move everything from list to flux, anything from object to mono. Make sure anything is blocking in your app. And sometimes playing with all the stack .map, .list, .flatmap, .defaultive empty, in the end is pretty elegant code. In 2 lines you do a lot of stuff, but at the same time, coming to this code sometimes it's a bit tricky. So now, which is neat with this application, you do have a full working app doing CRUD, create, read, update, delete, both for single entities and on groups of entities. And really, it's not really about all the decision I made to build the app. It's really, you have a running app with Spring Security enabled, with distributed tracing enabled if you wish. So use it as a template when you need to build an app. And this is what the Spring Pet Clinic community is there for. And you can see that a lot of Java developer and Spring developer really use these those repo to what I would like you to so gitcom.com/ this guy. So this is a reactive sample, okay, pretty neat. But here you do have the React.js for the UI, Angular for the UI, microservice, Kotlin, and it's not the same. Cloud, REST. I use REST as my base code to work, and I switch from this guy to the reactive one, moving from MVC to WebFlux and changing the data model because I'm using a NoSQL database. But here you do have GraphQL, you do have Cloud Config, Data JDBC, microservice config. So if tomorrow you wish to start an app on Spring, get a look at this community website and contribute if you can. I think they are doing a great job by providing ready-to-go samples. Okay, I was in speed mode. Do we have a question? why not we modify the UI and DB layer first? No. Yeah, because so I got your point. So at the initialization in after set properties, because I specifically invoke subscribe, the overall starting process will wait for this to be done. Yes, mono object flux list. Yeah, true. And flux or mono are really working like streams in the Java 8. Yeah, you get the map, your reduce, your and sometimes you are very tempted to go back to streams and start doing because you can stream as well flux. But no, you should avoid stream and stay in can because you don't want to block at any point. Okay, all right. So we went through the code review. You do have the sample running on your cloud instance, not your laptop. I hope it has been helpful to you. And nevertheless, you do have a working app now for you to use as a template. And so this is the logical architecture of the app. Okay, this is the one I've used, and this is the one completely built and started by Gitpod for you. And what Moritz did is define this guy as a submodule of this guy. And so when you open your workspace with that, this guy is already there. It has been pulled as a Git submodule. I was not aware it was possible. I found that pretty useful. Okay, that's the database, and that's stuff I did not enable on Gitpod. It's working with Docker, but you can do that if you start the app locally. Oh, so question about integration test. So for integration test, of course you don't want them to block, and so WebFlux provide a pretty nice web client. So it's not the default HTTP client or async HTTP client. It's called web client. And you do have the sample in the app in the SRC test Java. Thank you all for the session today, and thank you to Moritz, especially to first to provide the nice Gitpod platform we're all using every Wednesday to demonstrate what can be done on top of Cassandra, and also to be there today and to show and explain what is Gitpod and what you can do with it.
Yeah, thank you that I could be here. That was fun. I really liked it.
Yeah, that's great. And you know what? Both of you are doing the same in a couple of hours. So until then, thank you very much all, and see you next time. Bye.
All right. See you.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.